talk about this one. Distinguish between qualitative and quantitative variables. Okay, so let's see in here. Let's read first. What is a qualitative or categorical variable? Okay, OB, go ahead, please.
A qualitative or categorical variable allows for classification of individuals based on some attribute or characteristic, and a quantitative variable provides numerical measures of individuals. The values of a quantitative variable can be added or subtracted and provide meaningful results.
All right, thank you. So let's see some keywords in here for, again, qualitative or categorical variables. There should be what? Some what? Attribute or characteristic. Okay. Can be color, can be what else? Preference. Okay, what else? Favorites, right? Food. Okay, there we go. Taste. Okay, can someone give me some other attributes or characteristic that you can think of? Clothes, there we go, right? Choice of clothes. Color, there we go, yep.
What about height?
Height is basically what? It's a good question. What is called quantitative variable, right? Why is height called a quantitative variable? Let's see this one in here, all right? Go ahead.
What about size?
Yeah, let's read this first, the quantitative, right?
Quantitative variables provide numerical measures of individuals. The value of a quantitative variable can be added or subtracted and provide meaningful results.
Thank you, right? So, as you said a while ago, height. Oops. That's, yeah. What about height? You said also, what about size? Well, first, are they numerical measures? Got it? Okay. Oh, look at your shoe. Right. What shoe size is that? Okay. Mine is kid size, right? 7. All right. It's like, wow, that's so small, right? Anyway, so it's a number. Does it provide? Is it a numerical measure? Right. Okay. Can you add or subtract shoe size? Yeah. Oh yeah. Right. It's like, okay, if I'm a size 7 and say, who else? Well, I think I have the smallest feet in here. Typically, I will have the smallest feet. But who got some? OB, what's your shoe size?
11.
11. See that one? From 7 to 11, so you are like adding 4 sizes up, right? So when you can add or subtract, and that has meaningful result, yeah, that's a quantitative variable, okay? But when you talk about a while ago, color, oh, yeah. Well, my shoe is what? Black, right? Well, there are different variations of this. There's like tan, there's like camel, what's some like high-end colors. Neutral, right? What else? Opaque, is that a color? Opaque or something? Transparent, there's transparent. Okay, so yeah, if it's a color, so yes, there we go, right? Well, let's read in here, okay? Determine whether the following variables are qualitative or quantitative, all right? Oh, anyone who can tell us? Gender. Qualitative, right? Let's call it QL, right? Let's call it QL for qualitative. Okay. And let's call it QN for quantitative. Temperature. Ooh, how cold is it right now? Ooh, it's 20 degrees, right? A while ago, it was like what? When you were driving going here, what was the temperature on your watch? 14, right? Oh my God, so cold. Okay, so what do you know about temperature? Quali or quantitative? Quantitative. There we go. Okay, interesting. The zip code. Anyone in here who lives in Hickory? What's the zip code in Hickory?
28601.
28601. I live in Newton. That's 28658. Okay. Anyone who lives in Conover?
28603.
28603. All right. There we go, right? Yes, it's a number, but is it a numerical measure? No, it's not. So even if zip code is a number, it is not a numerical measure. With that being said, then this is what? Still qualitative. Again, it doesn't really mean that if it's a number, automatic, it is quantitative. There are some numbers that if you add or subtract, it doesn't mean anything. Are we good? Right.
It's like area.
Area code, right? Yeah. Phone numbers, right? What else? What other numbers are qualitative in nature? Qualitative in nature, right? They're numbers, but they're not numerical measures. We said a while ago, zip code, this one. Phone numbers, right? They are, I mean,
What about the date?
date. What do you think about the date?
I'm gonna say this.
Quantitative, because you can count the amount of days within each other.
If, okay, it's kind of tricky. If it's date, typically it's qualitative.
Really?
Okay, but if it is number of days since the start date, then you are counting, right? Then it can be qualitative. So it depends on how the date was used, I would say. Are we cool?
How about time? Like 9:46 right now.
Again, I would say the same as the dates, right? Because dates and time are typically the same, right? Like from 10 o'clock to 11 o'clock, all right? Are we cool with that? So if you're talking about how many minutes after it had started, like say it snowed in Blowing Rock. Did you see the snow in Blowing Rock? Anyway, we went to snow in Blowing Rock last Monday, right? Okay, because it's just basically like less than an hour drive from here to there, right? It's like nothing happening in here. You go to Lenore, it's like raining, and then you go to Blowing Rock, it's snowing, right? So like, how many hours had it snowed in there? So if talk about how many hours it had snowed in there, then it's what? Quantitative, right? But if talking about like, just the time, right? Then it can be called a qualitative. So it's kind of tricky in some cases. Depends on how you use the data for, okay? Let's continue in here. Discrete and continuous, right? Let's see in here which one is discrete and which one is continuous, okay? Let's read the instruction first. What is a discrete variable, okay? Anyone who can read it from there? Juliana? What is a discrete variable?
A discrete variable is a quantitative variable that has either a finite number of possible values or a countable number of possible values.
All right,
The
so
term
again.
countable means that the values result from counting such as 0, 1, 2, 3, and so on. A discrete variable cannot take on every possible value between any two possible.
Okay, continuing. Continuous.
A
Julian.
continuous variable is a quantitative variable that has an infinite number of possible values that are not countable. A continuous variable may take on every possible value between any two values.
Okay, so for example in here, when you say every possible values between any two possible values cannot count. Like for example, if I say this is 3 and this is 4, right? Let's say 3.7, right? This have no meaning, right? Have no meaning. For what? For a discrete variable, okay? But for a continuous variable, between 3 and 4, 3.7 means something, right? So if values in between integers, all right, or whole numbers actually mean something, then it's called continuous. Other than that, then it's called discrete. Okay, so that will be our last agenda for today. Let's talk about this. Which one is discrete and which one is continuous, right? Let's read letter B. Okay, let's see in here. The number of cars that arrive at McDonald's drive-through between 12 and 1 o'clock. Number of cars that arrive at a McDonald's drive-through between 12 and 1 o'clock. Is it discrete or continuous? Discrete, right? Why? Because talk about number of cars, right? right? So I would say in here, there is no, say like what, 42.7 cars. What's that? 32.7 cars. Like 42 cars and one with us three tires or something, right? So it cannot be possible, right? So it has to be what? An integer number of cars. Okay. So which among these now is continuous, right? So this is what? Discrete. Which among these is continuous? A or C?
C.
C, the distance, right, of a 2020 Toyota Prius can travel in city driving conditions with a full tank of gas, right? Good. So let's say it traveled like say what? 253.8 miles. Is it possible for it to drive like 253.8 miles? Yes, right? Good. So if numbers between integers does mean something in terms of mileage, then yes, it has to hold. Be good? Right, thank you. Any questions regarding